Hello, everybody, and welcome to this year's HasuraCon. My name is Boštjan, and I'll be telling you about how we integrated Hasura into an existing GraphQL ecosystem with remote schemas. So this is going to be a bit weird for me. It's my first time doing a pre-recorded talk. So what I usually do is I do something to break the ice, but because there's nobody there on the other side, I'm just going to imagine like there's a bunch of people out there that's listening to me, and I'll try to be as alive as possible. So a short introduction. I currently work at a company called Result, and where I'm kind of doing stuff related to GraphQL. My other work is connected to doing teaching for Smart Ninja, Rubio, and Thinkful. So there's a lot of stuff that I'm doing on the side, and that's basically it. So for a short intro, I'll just tell you what we'll be talking about today. So what we'll be doing is we'll be doing remote schemas and remote joins and checking out what this feature offers to you. We will also be presenting an infrastructure that works really well for remote joins for us, and we'll also be showcasing a small demo. So even though we won't be having like a live Q&A, I would kind of like to invite you to post stuff on this Jamboard that's linked in this QR code, and I'll try to respond to your questions after this talk is played out. Okay, so let's get started. So, and by the way, if you get bored during this talk, there's like songs at the top which you can listen. So they are related to the titles. I've tried my best. Okay, so Hasura gives us CRUD, so create, read, update, delete, and real-time GraphQL APIs out of the box. It also gives us access and authorization control. But what if you want to do some custom business logic? Or what if we have an existing GraphQL server with some data in it already? Well, something like this. So let's imagine that we have a GraphQL server somewhere out there, and we are using the Hasura GraphQL engine as well. Basically, remote schemas allows us to merge an existing GraphQL schema into Hasura itself and also use it through Hasura as well. And this is basically from the Hasura documentation. So we have like an app which communicates with Hasura, and Hasura is able to communicate with other GraphQL services and also the GraphQL it has created for us. So some downsides to this approach, we don't have subscriptions yet, but we'll get a little into that a bit later. And also currently there aren't a lot of public GraphQL APIs which you can use for this, but let's think in terms of the future, just like the Hasura team is doing. So let's do a live demo so that I just won't be talking into the blank. We'll be building a small app with Hasura, Apollo server, and some services on Node.js running with MongoDB. Of course, some of the code is pre-built. And first, we will showcase the remote schemas feature in Hasura and how it works. A reminder that we aren't caring about security here, so some of the things aren't done here. So in the end, our thing will look like this. So we'll have a Hasura server, which will connect to Apollo via remote schemas, and Apollo will connect to the user service as well. So this is just like a small, undercomplicated architecture, but imagine this. Yeah, so let's go into the demo now. So we'll be building a small blog post app, and I'll just be creating a post table for now. And of course, we'll be creating a table called post, which will contain an ID, description, or let's say content to it, which will be text, and also an author ID, which we will dive into later, which will contain the ID of the author that is posting. So nothing new here. We'll just create this table, and it will show up here. Now, this is the remote schemas tab, which is going to allow us to connect to another GraphQL server. So I have this one pre-prepared as well. So we have like a query on it that's called tensor user, which fetches a user from the MongoDB. And we also have a small mutation which registers as a user. And what we'll be doing is we'll be adding this remote schema by just clicking the add button and naming our schema. And we'll be adding it from the environment variable. So this can be added to your containers. So let me just copy the environment variable now, because I don't know it. And we're going to be forwarding all of our headers from the client as well. So I'll just put a timeout here as well. And the remote schema is now added. And if we check our schema now, you can see that besides the post that we've created, so the delete post, insert post, and update post mutations, and also the post query, we also now have all of the queries and mutations from the other GraphQL server as well. And that's basically what remote schemas does. So we can just query users by ID and register users as well, which I'm going to do right now. I'm just going to register a user, and I'm going to provide an email here. It's like this. And I'm going to trigger it and just fetch the ID from it. Okay, these are remote schemas, a very powerful feature, and it's also very simple to implement as well. So let's go back to the presentation now. So we added another GraphQL server and its schema into Hasura, and our frontend can all call all the queries and mutations it needs. But what if we could also add relations to another GraphQL server? What if we could automatically do joins with the data we have in Hasura? So remember that author ID we did? That is basically some sort of foreign key. Well, we can really do that, and it's like a mind-blowing explosion thinking about that. And this is an absolutely insane feature. So imagine our post table we created. So we have that ID, which is the primary key, and the content, which is the text. And then we have the author ID, which is basically a character regarding to the terms of the database. But let's say that we call this a GraphQL foreign key. And this is basically what remote joins do for us. They offer us the ability to actually create a foreign key which references another GraphQL query on another server, and it can automatically join the data for us. And let's see an example call. So we are fetching a post where the ID equals 1, and we also fetch an author with the data we have in our existing Mongo database. So the first name, the last name, and the ID. And what happens is the post gets called from Hasura, so we fetch that data, and the author ID, which is also written in the content, we'll show that in the demo later on, will fetch the data from our Apollo server and automatically join the data together. So if your relation does not exist, it returns an empty object or an error, depending on what your implementation looks like. But this is basically what remote joins do. So instead of having two tables connected together in a database, you can actually connect your data to another GraphQL server, just like if it was a Postgre table and we had some relations on it. And let's kind of see the live demo of this right now. So on switch. Okay, so remember the user we registered earlier, so let's register another one because I've just lost his ID and I'm not going to bother with it. So this is the ID that I will write into our post table. So let's insert a row. This is my text, and let's insert the ID of the author that we've just added to our schema. There's some weird stuff going on because my mouse keeps disappearing. Okay, it came back. Okay. Okay, so now I've inserted a user and a post, and so let's now try to fetch this. Okay, is the screen not showing or? Okay, so let's try to fetch our post now. And also, before we do that, we need to actually add a remote relation. And this is done in the relationships table, and we can add a remote relationship by clicking here and giving this relation a name called author and connecting that to our remote schema. And we can actually connect this to our author ID column, click save. And what's gonna happen is we're going to browse our rows here, go into GraphQL and fetch the data we just did. So now what happens is I can fetch a post and also fetch its author, its email, first name, and last name. And this is what actually happens. So the data gets connected together, and this is what remote joins actually do. So let's go back to what we just did, and we can see that this is a really powerful feature which actually allows us to do major stuff. And I'm going to just give you an example of what we did with this. So we decided to use remote joins and schemas to our advantage by creating an ecosystem for our applications. So we have like a GraphQL server dedicated to common things in the ecosystem. So these are like a user service, a code register service, a storage service, and also a service that saves our files. And this is like one part of the ecosystem which is used in all of the other apps. And we kind of popped Hasura into that by using the remote joins feature. So what happens is now we have like a small app team which develops our app using Hasura, and all of the tables that are created inside the database can use remote joins and remote relations as well to kind of pull out the pieces of the Apollo server. So like getting a user off a post table like we just did. And this is actually quite powerful stuff. So our final schema looks like something like this. So we have an Apollo server and we have the services underneath. And basically this allows us to actually add any other existing applications into this ecosystem by just building different Hasura servers and using remote joins to connect the data together. So this actually gives us a future-proof ecosystem which allows us to build apps and also speed up our development. So the benefits, okay, we have CRUD with Hasura. This allows us to easily scale our GraphQL. And we also have reusable components which we can use in any of our Hasura applications. And the main plus is it allows us for faster development time of new components and apps. So we can kind of have separate teams, one team that takes care of the main part of the system, and the other teams are actually developing applications. So there are pluses and there are also minuses. So you can expect that there are some weaknesses. So for now, we don't have any subscriptions with remote schemas. But if you think about it, we don't actually need them because users aren't live data anyway. So their emails, their names, they won't be changing a lot of the time. And also, depending on our implementation of the GraphQL server that we're doing, it can slow down Hasura's performance. So you actually need to take care of that on your end. And I'd like to offer you some cliff notes. So authentication and authorization. So you need to take care of this on your own. So if you have another GraphQL server that's connecting to your Hasura server, you need to do your own authentication and authorization of the data. So the Hasura team has already noted that in future versions, this will be taken care of. But for now, you need to take care of this on your own by either using JVT tokens and checking them on your Apollo server or any other server implementation and checking for the same permissions if the user has them or not. Performance-wise, it can affect Hasura's performance as noted earlier, just like WordPress plugins affect WordPress on its own. So you need to take care of any performance issues like caching and batching and stuff like that. And the fourth line here, so actions versus remote joins. If you've been watching the online calls with Hasura, there's another thing called actions as well. So we don't see remote joins as a replacement for doing custom logic with actions. We actually see them as something that can allow you to build a vast ecosystem, or maybe kind of chunk your GraphQL schema into pieces and do easier scaling on it. So there's an ongoing discussion regarding this. I welcome you to join me in the Jamboard discussion into why would somebody use either remote joins or actions. So these two are kind of interconnected together for us. So the future, so the Hasura team is working on merging this feature into the main branch. We were told that you can expect it in 1.3 beta. And this is actually something we really look forward to because it really takes your app development to another level. It also takes GraphQL to another level because if you think about it, you can create different small GraphQL servers and just connect them together into one bigger graph. And that is kind of the main thing we like about remote joins and remote schemas because it allows us to scale the graph much easier and also create reusable components as well. So imagine doing a GraphQL API for, I don't know, a REST service. Let's say that service is Google Maps or something like that. And you can just create that GraphQL server using any GraphQL server implementation out there and just do a join. And you can also reuse that into any other app that you're building in the future. So this is why this is a very powerful feature for us. And we also think that it's a powerful feature for future GraphQL development as well. So we're nearing the end here. I would like to thank my team that's involved in our GraphQL department, because without them, nothing like this would be possible. And I would also like to thank the Hasura team for doing great stuff in the GraphQL world. Without them, any of this wouldn't be possible. So if you would like to keep the discussion going, please connect with me on LinkedIn or Twitter or follow my Medium posts. The source code for this project will also be available in the following repository. So you can download it and play with it. And also, I've got 30 seconds left. I'm sorry for all the bad stuff I was saying in the middle. So there were some technical difficulties on my end. I would like to say, graph on, keep the graph going, enjoy in your GraphQL development, and also visit our website to see what projects we're doing. And that's basically it. So have fun during the Hasura conference, and I hope I'll be seeing you live in the near future.